At Nexteer, the rack-based electric power steering system, also known as REPS, is tested physically in an end-to-end impact test. During the test, an actuator accelerates the rack bar up to a certain velocity and releases so that the momentum of the rack carries it until it impacts the travel stop on the rack housing. These tests are pass-fail depending on the performance of the subcomponents, and data is not collected, which makes it challenging to analyze the system's behavior. An Excel-based digital engineering tool will expedite the design and prototyping stages for Nexteer engineers, as it will allow users to test endless combinations of system design parameters and analyze the system's behaviors without having to physically manufacture it and run its impact test. This will save both time and money, as it will allow Nexteer to optimize their critical components through the use of theoretical data produced by the simulation. We are Senior Capstone Design Team 19, and we are working on the digital engineering tool for impact assessment and rack-based EPS systems for Nexteer Automotive. I'm Sabrina Jensen, and my teammates are Codi Anderson, Jacob Bart, Gita Deonarain, and Heath Haverdink, and our advisor is Dr. Jeremy Worm. When approaching this problem, usability and accessibility were some of the main design objectives that the team had. Great consideration had to be taken for the end user's program knowledge. Based on this, Excel was assigned and chosen as the primary and only program used to run and process this simulation. In the REPS simulation, the user can begin by either selecting a preset combination of REPS parameters or entering their own combination of parameters. Once these parameters have been set, then the user will click the Run button, which will then run the VB script containing the dynamic equations for an impact event and calculate the motor's shaft angular velocity, angular acceleration, torque, and the ball nut bearing axial force, as well as the travel stop axial force. Then the user can view the maximum value of each dataset and/or plot any of the datasets by clicking on the Plot button above them. If the user wishes to run a new simulation, they will then click the Reset Simulation button, enter in a new set of parameters, and click the Run Simulation button once again. A vital component of this design is the user manual for both the interface and the VBA code. This user manual will help both simulation users and holders to understand how to operate this tool, as well as customize the script so that it can accommodate for any new dynamics or additional outputs that are desired. The next steps that the team advises regarding the model's dynamics and maintainability include the following. With regards to the dynamics, further testing of physical components under both low and high impact conditions are required to complete the full representation of the REPS assembly under both conditions. The model currently is only able to predict values under low impact conditions. With regards to the maintainability, if there is a need to update the equations contained in the Microsoft VBA script, and this poses a challenge to the user, other options of transferring such information to an Excel sheet within the simulation may be explored. We would like to thank Nexteer for allowing us to work with them as they move to more digital-based analytics of their designs, and we know that tools like this will allow them to verify and optimize other tools to be incorporated in the future. Thank you.